Okay, so if I've got a piecewise function and I know that f of x, so it's given to me as f of x is equal to 2x minus 1 and 3x minus 2 and then 0, but this domain is from greater than 0, less than or equal to 3, for x greater than 3, and then otherwise it is 0, and I am asked to sketch this function. How would that function look? Okay, so let's get our x's going. Let's get our y-axis. Let's get our x-axis going from here. And what we have here is, so 2x minus 1, firstly. If I make x equal to 0, y will equal negative 1. Okay, if I treat this as an equation, y equals 2x minus, if I make y equals 2x minus 1, and that's my y-intercept. If I move this over, it becomes negative 2 divided the other way, it becomes a half. So x-intercept is going to be a half. So this is 1, then a half would be over here. All right, so that's going to be the function, but it's starting from 0 and it's going until 3. Okay, so it's going to continue 1. If that's 1, then that should be 2, and then that should be 3. So I know that this function is a straight line starting at 0. So it's not going to go past 0 because it's the x value for 0 starts here. And it's going to continue up to a certain point. Actually, I should keep it as a solid line like that up till it gets to 3, which is there. Okay. If I need to make more space, I'll have to just adjust my diagram. The next one I got is making x 0, I get negative 2. All right, so negative 2 would be over here. And if this is y is equal to that, and I made y 0, I get 2 divided by 3, which is 0 0.6. 0 0.6 is something like that, which means that this function is going to travel all the way from 3 onwards. So it would go this way, but it would continue from 3 onwards, which is something like there. I can't seem to fit it. Right. So what I'm going to do, I'm going to try and move this whole thing all the way down. Okay, so I'm going to try and move this whole thing down. Let's see. I'll move this whole thing down. Yeah. I'm just going to move that down there. Okay. And I'm going to extend this line a little higher. And what I have is, I have a steeper gradient. So this line should go all the way this way. But technically, it's not starting at 0. It's starting at 3. So if I go up to 3, it's going to start around there, actually, by the looks of it. So sketching this function means that I have to shorten this line and make it start there. So I'm going to shorten this line and make it start there, which should be around there somewhere. But now what we have is another thing, which is the fact that we're including this over here, and here we excluding that over there. And they're sort of overlapping. That means for certain x values, we'll have the same y values. I mean, if I take 2x minus 1 and I make it equal to 3x minus 2, if I'm drawing this perfectly, then let's solve this quickly. It's going to be x, that's going to be 1. So for x equals to 1, they're going to be equal, and that's it. So they're not going to meet there. But when x is 1, they're going to cross each other's paths, just there. And if I put 1 into here, I get 2 minus 1, which is 1. Put 1 into here, I get 3 minus 2, which is 1. So at the point 1, 1, they would have crossed each other's paths, but this one continues from 3 onwards anyway. And that implies that we have to have some kind of open circle. Okay, so that open circle means that it's excluding 3, right? Because it's not equal to 3. So we have to put an open circle there. And we put a closed circle over here because that implies that it's including. And then we put an open circle at the end here because that's excluding as well. So whenever we exclude, we put an open circle. Whenever we include, we put a closed circle at the end of the line. Now so now we can go to the last part. The last part, it says y equals to 0. Otherwise, well, this is my y-axis, this is my x-axis, and y equals to 0 is here. So otherwise would mean, using arrows, it will be 0 otherwise for any x value. So that means including that part, it will be 0 going this way. And that's it. Will it be 0 between these two? No, because it continues from one to the other. All right, so there's a bit of a technicality just here, and this is where, if you see this line here, this should be exactly above. This line should be brought into 3, or this one should be brought higher, like there. Yeah. All right, then that will be brought closer maybe, but it's continuing. The next question is it jumping? How do I know where to start this line? The only way I can find anytime I need to find out if it's jumping, I can take x equals to 3 and substitute it into each function. All right, so let's go ahead and take x equals to 3 and substitute it into this function. 2 times 3 is 6. 6 minus 1 is 5. 3 times 3 is 9 minus 2 is 7. We know that this over here is going to be starting at the point 7. So if I have clear values here, which is 1, this was supposed to be 1, then this would be 2, 3, 4, 5, 6, more or less. Hopefully that's correct. If I put 3 in here, I get 5. Okay, so I should just maybe label that part. So I know this here is going to be 3 and 5. But this one over here, if I put 3 in here, I get 9 minus 2, which is 7. So 7 is going to be, that's 5. Let's go 1, 2, 3, 4, 5, 6, 7 is actually over here, which means that this line should start there and be excluded. All right, now I'm just sketching this, right? I'm sketching this and I just need to label it correctly as well. And I probably got the gradient lightly out, so it should be going this way. Okay, so that it can, if I have to extend it, it's got to go through there. It's actually got to go through there at some point, somehow. So that would be the most accurate version of that. And then also excluding it, right? So we're excluding it like that, going this way. Okay, so there we go. How do we know every single part of, so I'm going from negative infinity. So everything is, this entire domain is included in this line. And then the entire x values is included until there. And then it continues after that. So that includes everything from there up till there. Does it stop at 3? No, it continues after 3. This one is taking me to positive infinity. Otherwise means it can go into negative infinity after that. So the orange line takes me to infinity, and the red line takes me to negative infinity on the other side. So we have to put an arrow to imply that it's continuing into infinity, unless they actually stop it somewhere, in which case this will have to be less than another number, like less than 4, or this one would be less than 3. Then we have to actually put another circle, or empty circle, or open circle, etc., etc. Now sometimes you get given functions and you've got to find the equation, and we go backwards. So if we're given a function, we got to find the equation. And let's suppose we have these lines. So I'm going to just draw some random lines here. Let's say I got a line going this way. Well, let's make it a solid line. Okay, so let's make it that, and let's make another line starting from here. but going this way. And let's suppose I've got another line at the bottom, which is starting from here and going downwards. Okay, it's a piecewise function, and I need to find the equations of each of these functions. This one's going to be solid. This one's going to be, let's say, open. This one's going to be open over here, and this is going to be solid over here. And this would be, let's suppose this ends with an open, and this continues till infinity. Okay, so I've got y and I've got x. Let's give it some values, and let's see if we can find the exact functions for this. If I give it some values, let's suppose this number here looks like it can be maybe 2. So let's give it the number 2 on the x-axis. And if that's 2, then it should be 2, 4. So let's say this number over here is -6. We're going to try and label as much as we can. And just looking at the graph. So 2, 4, 6. And I'm just going to use round numbers. So this is going to be 8. Okay, 8 is going to be in line with those two. And that's going to continue all the way there. That way. I also know that this is starting at 2, and let's give it some y value. So this is 6. This is 6. So it's going to be -2, -4. So let's stick with this distance. 1, 2, 3, 4. 2 again. All right, so let's say that ends up over there. And let's just make sure this one is a nice number. Let's make it 5. Let's make it 5. It's closer than 4. So this is 5 over here. So we're given all this information. We're given the coordinates wherever they meet, as much of it. And this one here is -1, let's say. And I am asked to find the equations of these lines. Okay. So if I'm asked to find the equations of these lines, all I have to do is look at the starting point and ending point. If there's anything we're missing, we'll add it in. If there's anything extra, let's see why as well. So firstly, I don't have another point on this line. So let's provide one more point here. Let's suppose if it's 10, well, let's make it 8, 10, 12, yeah, then this would be 6, let's say. So the point 12 and 6 lies on this line. Yeah, can you hear me? Yeah. So now we want to find this equations for each of these. And I'm going to call, so this is going to be f of x, and it's going to be equal to these 3 functions one by one. Let's start with the blue line. For the blue line, I've got the coordinate over here to be 8 and 5. And I've got 12 and 6. So I can use the 2 coordinates to find the gradient. 6 minus 5 is going to be 1. That's my gradient and of the blue line. And 12 minus 8 is 4. So therefore, y equals to 1/4 x plus c. And then I substitute, let's say 8 and 5 in there. I put 5 in there. I put 8 in there. I get 5 over 4. 8 minus 5 over 4 equals c. That's 32 minus 5, which is equal to 27 over 4. So therefore, this line is going to be y equals to x over 4 plus 27 over 4, which will be my c value. And 27 divided by 4 goes into there 6 times, remainder 3/4. So that's going to be where this would actually go through. Let's double check that. So this is 32 minus 5, which is 27 over 4. 4 goes into 27 6 times. Yeah. Okay. Okay. And let's just double check that. That's going to be 6 minus 5, which is 1. Y, x changing y would change in x. 12 minus 8 is 4, so that's correct. Then I substitute, I got my x and y the other way around, right? So you can see this is going to be 5 equals 1/4 times 8 plus c. That's better. And it becomes 2. 5 minus 2 is 3. Okay, 5 minus 2 is 3. So this line is obviously not drawn perfectly. So c is equal to 3. X is equal to 8, y is equal to 5. Okay, so this becomes y equals 1/4 x. Let's write that down in here. 1/4 x plus 3. And my restrictions is that x is greater than 8. And that's it. Okay, so x is greater than 8. All right, let's go to... So this one will be strictly greater than 8 because of that open circle over there. So what we have to remember is, if I put it in this box here, whenever we have any open circle, then it will be greater than or less than. If it's a closed circle, it will be greater than or equal to, less than or equal to at that point. Okay, let's go to... So the next equation is going to have a closed circle and an open circle, right? Which means the next equation technically is going to be greater than 2 and less than or equal to 8. Okay. And the coordinate for this is 8, 4. The coordinate for this is 2, 0. So if I use those two coordinates and get the gradient, 4 minus 0 is going to be 4. So y is equal to 4, and 8 minus 2 is 6. So 4 over 6x plus c, which is 2 over 3x plus c. And let's say I change it into 2 and 0. So I make this 0, and I change x into 2. So it's 2 over 3 times 2, which becomes 4 over 3. So therefore, c will equal negative 4 over 3. So this equation will become 2 over 3x minus 4 over 3. And that makes sense because it's going to go into the negative space, just below 1 as well. Okay. And in the next equation, I've also got the coordinate over here. This is 2, negative 1. And I've got another coordinate over here, which is 0, negative 6. And with that, I can find the gradient. Minus 1 minus minus 6 is minus 1 plus 6, which is 5. And 2 minus 0 is 2, so 5 over 2, x plus c. Substitute 0, negative 6, making this 0. C becomes negative 6, and I can see it's negative 6. All right, so this one's going to be 5 over 2, x minus 6. And this one starts at some point over here, okay, which we did not state. So let's just say this point over here was negative 2. Then x is going to be greater than negative 2, but less than or equal to 2. Because that's a closed dot. So it's that. This is open, so it's going to be that. Okay, and it's got a piecewise function. We've now developed all of that. And we also know that x is an element of all real numbers. Okay, if it says 0 otherwise, let's say we add another one. It says 0 otherwise. I can't state that because it's not on the graph, right? But if it is on the graph, then it would be a straight line from here going that way. And that covers the whole domain because this is going to go negative infinity and the positive infinity is coming from the top there for this one. But it's not there, so we don't have to worry about that as well.